So I hope you can see me and hear me very good. I will start straight there. I've just given me a short overview of what my activity at CANopen, so to point you out why I'm doing this presentation today. Besides supervising the CANopen special interest group various, I'm doing also testing, actually CANopen testing, and now also CANopen FD testing. So then I would like to share with our experience and what we did, what we do, and what we will do as well, since the topic says today and tomorrow. So for testing, CANopen FD application layer, as the previous presenter, Mr. Schwager said, and Mr. Seltwanger, we do have already 2 application layers based on CAN. This is CANopen and CANopen FD. My topic is addressed to CANopen FD, and its application layer, which we are testing. We do not test data link layer, we do not test physical layer, but purely application layer itself. But the point is of this slide, for example, is to say that CANFD is the underlined data link layer, which is using CANopen FD, has some big advantage or some additional advantage over the classical CAN. It offers 64 data bytes and also some higher speed concept, but we're concentrating ourselves on payload. And payload affects actually which new communication services will be available, which we cannot have in classical CANopen. So this means actually it has this corresponding impact on that. And if we take a look into the internal device structure, just a couple more slides about this general concept, we see the object dictionary, as the previous presenter already said. The object dictionary is a database where device itself from application software, you can see, and protocol stack take the parameters. So they are not stored in protocol stacks, and application specific parameters are not stored in application software. They are stored in a single modular, making a modular structure in a single database called object dictionary. So this simplifies, of course, the access to the device, but the device is considered as a black box itself for the testing. So we don't test protocol stack and we don't test application software itself, and neither do we object dictionary alone. So we do the whole piece as one. Additionally, in contrast to people here with a different background who are doing their own CAN application, CAN FD, CAN Excel application layer, we have this CANopen standardized. CANopen FD goes also in this direction. It has a unique way to identify the device, not by the message ID, but there is certain specific device device identification, and that requires actually a configuration of it in a network to know which device I will go into address and test. So for this one, we have multiple methods to do so, to design actually how do we assign this node ID. You're welcome to visit or to attend our CANopen seminars or webinars to learn how to do so. I'll concentrate on CANopen FD specifics. They support all these methods, and beside that is also a very specific software base called layer setting services configuration. The specification itself is also for CANopen FD. They are different, CANopen and CANopen FD one, because they are different concepts, slightly different concept, additional concepts embedded into this. That is to know with the testing itself. CANopen FD bit rates are different than in CANopen. CANopen we have 8 bit rates for the choice, and at least one should be supported. Shall be supported.